Graph x plus 2y equals 5. Let's form a t-chart here. So let this be your xy chart. Let's assign values for your x. Values for your x, 3 values. We can have maybe -2, 0, and maybe 1. All right. So if your values for x are -2, 0, and 1, what are your values for y? Let's start from -2. If x is equal to -2, what's your y? We have your x plus 2y equals 5. Plug in. Your x is -2. Let's see if we can make use of this, or we can avoid integral values. Let's say, let's avoid fractional values. What if x is equal to -2? Can we get integral value? Maybe we can change that later on, because if it's decimal, then it would be difficult to approximate. Okay, so might be that x is not a good number. Maybe we can use a -3. All right, let's change that to negative. If you are good at approximating points, even if it's decimal, then go ahead, use decimal. But I suggest use integral values. Come up with integral values for your y by assigning values for your x that can create an integral value for your y. But this is not the only method we use for graphing. Okay. So let's change this to -3. All right. So now we plug in -3 to x. Which one do we plug in? -3 to x. And then, thank you. If x equals -3, then we plug in -3 to x. And so this is now -3. Your x is now -3. It is +3 +3. So what do we have there now? This is 2y. 5 plus 3. You have 8. Divide by 2 both sides. Your y will be 4. If in the end your y is not integer, you can still change it. But if you are good at approximating decimal in your Cartesian plane, why not? But I suggest you avoid that, so that you'll have a more accurate graph. You can change numbers, right, for your x. So your y here is equal to 4. So that's the first ordered pair that we have, -3, 4. Let's find another. What is your y if x is 0? Oh, it's not integral again. So maybe we can use 5. You want to use 5? Okay, let's use 5 then. You're the boss here. You can you can change your x. You can use your x. So let's continue here. So if x is equal to 5, then we have to use this equation again. X plus 2y equals 5. Plug in 5 to x. Yes, you can. Well, let's continue that. If it will not give you integral value, we can change that again. So your x is now 5, right? So we plug in 5 to x. So this is -5 minus 5. The 5 minus 5 is 0. We have 2y equals 0. Well, 0 is integer, so we can have a value. We divide both sides by 2, so you have 0. So yes. Do you think 1 will give us integral value for y? Yes. Okay, let's see that one. So if okay, if x is equal to 1, using your x plus 2y equals 5, plug in 1 to x. That means we now replace x by 1. Minus 1 here. You have 2y equals 5 minus 1. 4 divide by 2, y is 2. Again, we got integral value. So that's what I'm saying. In order to graph it easily, a more accurate graph will be obtained if your x and y are integers. Well, what if it's decimal? Then maybe you can change your values for x until such time, until you get a y value that is integer. So it would be easy to plot these points. Let us plot negative 3, 4. Negative 3, 4. Where is it? 3 units left. 1, 2, 3, and 4 units up. 1, 2, 3, 4. There's your 3, negative 3, 4. About 5, 0. There you go. 5 is in the x-axis. 1, 2, 3, 4, 5. Is that it? 0. No up or down movement. There you go. How about 1, 2? 1, 2. 1 right, and then 2 units up. 1, 2. This should form a straight line. By looking at it, do you think you will form a straight line here? Yes, I believe so 100%. If your line is not straight, then you're doing it wrong. Okay, so this would be your graph for x plus 2y equals 5. Let's put the coordinates of the point that we have here. This is negative 3, 4. This is 1, 2. And this is 5, 0. And I think we are done. We are done for this graph.